You study for 3 hours. The next day, 82% of that information is gone. This rapid data loss occurs because of a systemic biological mechanism independent of personal effort. In 1885, German psychologist Hermann Ebbinghaus sat in a room and memorized 2,300 nonsense syllables. By testing himself at precise intervals, he measured the exact rate of memory decay. This chart plots the Ebbinghaus forgetting curve. Without intervention, human memory drops by 42. New information sits in the brain like wet concrete. It remains in this fluid, malleable state for exactly 20 minutes. To trigger permanent storage, a specific cognitive action must occur before that 20-minute window closes. If the window shuts without it, the trace dissolves as the concrete sets empty. Standard review methods, like dragging a highlighter across a textbook or reading a chapter a second time, fail to initiate this structural transition. Memory survival relies on the biological timing of what you do the moment consumption stops. Highlighting and rereading create a convincing illusion. They feel productive because the information is visually familiar, even though the brain remains entirely passive. The brain operates on strict energy conservation. It discards data that simply washes over it, only encoding information it is forced to retrieve from scratch. Memory is a physical neural pathway. Rereading is the thin, dashed line, like standing at the edge of a forest looking at a path. Active retrieval physically walks that path, reconstructing it, making it deep, thick, and solid with every step. If a study technique feels easy, it is likely failing. Without the cognitive struggle of reconstructing the data, the brain refuses to commit it to long-term storage. The mechanics behind this struggle were mapped in 2013, when neuroscientists at MIT observed memory consolidation at the cellular level. They observed that neurons in the hippocampus form temporary connections when you first learn something. To cement those fragile links into permanence, the brain requires a specific protein. That chemical glue is brain-derived neurotrophic factor, or BDNF. Passive studying produces almost none of this essential protein. Instead, BDNF is manufactured specifically in response to effortful, intense cognitive activity. The intense, sometimes frustrating friction of trying to recall a fact sends a signal to the brain. This difficulty serves as proof that the information is critical for survival. The effort of recall is the literal chemical factory manufacturing long-term retention. You can control this chemical process using a 13-minute protocol. The timing is essential. It must be executed immediately, before the 20-minute window closes. Step 1 is to close everything. The books, the notes, and the video must be physically hidden to ensure the brain is retrieving information rather than copying it. Step 2 is an 8-minute continuous brain dump. Write down every fragment, keyword, and concept you can recall. Do not stop to organize or format. Simply force the data out. Step 3 takes 5 minutes. Open your materials and review them solely to patch the specific gaps your brain could not retrieve. This chart compares outcomes. 3 hours of passive study yields the low bar on the left. The failure to remember is a biological failure of timing, rather than a failure of intelligence.